Okay, now that we've gotten a little bit of an exercise on how to do prime factorization, well, how do we use that? Because it doesn't really look like that'd be very useful in fractions, but this is how we use it. Let's say we're looking at a number such as 10/20ths. Now we know what that describes. It describes 20 different pieces. That's the what kind, but we only have 10 of that amount. Now the question is this in reduced form? Well, it's tough to say, oh, well, let's look for a number that divides into both. That's the way that we used to do it. In fact, the way that I want you to attempt this at first, while you're still getting used to the division, is to turn them into its prime factorization like we were doing a while ago. Okay? And so 10 would be considered the same thing as 2 times 5, where 20 is considered, and we can do this over here. I think we actually had already done it, but 2 times 10 and 2 times 5. So 2 times 2 times 5. All right. So we're going to come back to this in here in just a second, but we're going to go through a little bit of a property. Property in fractions says that if you have a numerator over a denominator such as 6 over 3, this is the equivalent to 6 divided by 3. They are the same. Fractions do represent division. And so the solution here would be a 2. So what happens if we're writing a fraction such as 4 over 4? As a fraction, we might not recognize it, but as a division problem, we do. And that is 4 divided by 4, well, that equals to 1. And in fact, anytime that you have a 5 over 5 or 6 over 6, 7 over 7, it doesn't even matter. -8 over -8. Any number divided by itself is always going to equal to 1. Okay? So, we're going to come back to this. If we have rewritten this in the prime factorization form of 2 times 5 over 2 times 2 times 5, what I'm looking to see if there's any kind of combination that I can reduce, such as the 5 divided by 5, that gives me a 1, and the 2 divided by 2, that gives me a 1 as well. And so in its prime factorization form, this represents 1 times 1 over 2 times 1 times 1. 1 times 1 is 1, 2 times 1 times 1 is 2, which tells me that 10 over 20 reduces to 1/2. And if you think about that, that does make a little bit of sense. 10 is half of 20. So it makes sense that it should reduce to 1/2. Okay? So trying this again, let's say we had 16 over, we'll say 24. If I start to reduce this to prime factorization form, this becomes, and you can do this to the side to check it, but it is 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. And then 24 would be 2 times 2 times 2 times 3. 2 times 2 is 4, times 2 is 8, times 3 is 24. Now you might be wondering how I'm doing this so fast. It just comes with a lot of years of practice. Don't feel like I'm not getting it that fast. You will get there. It just takes a little bit of practice. So turning this number into a prime factorization allows me to simplify it a lot faster by looking for the cancellation of similar numbers. The 2 and the 2 cancel out. That 2 and that 2 cancels out. This 2 and this 2 cancels out. And so what I'm left with is 2/3. Okay? So practice 4. You're reducing of fractions. We'll try 15 over 35. We'll try 12 over, we'll say, 28. And then we'll do 16 over 45. Okay? Now, just a little bit of an advance warning. What do you do if it doesn't simplify? You just leave it alone.